Hello everybody! In this video, we're going to be teaching you all about grain shifting calculations with Summarize. What the heck is a grain shifting calculation? Well, you've probably run into this problem before and didn't know what it was called. And actually, maybe called something else. That's a name I made up. I don't know if there's an official name for it. There probably is. I call it grain shifting. The basic problem is you've got data, usually sales data, where some of the columns are stored at a different level than the sales transactions. So a common example is, and the one we're going to work through, is things like shipping fees, right? So for every order, there's a shipping fee, whatever it is, 20 bucks or whatever, right? But the table that you're working with has one row per transaction. And so that $20 appears many times, but you only want to count it once, right? Because it only happens once per order, right? So the data might look something like this. I'll pop over here to page 1, right? So here's sort of a snapshot over here. It's just this, a snapshot, but I put some yellow lines in there, and the yellow lines indicate the different orders. So let me head back to the main page here, right? We've got several sales transactions. This is the sales table for what it's worth, right? And here's all of our different sales transactions, and we've got, the items that were sold, the units, the sale amount, who the customer was. I know normally it would be like a number, but we'll just use a person's name right here. And we've also got an order number, and then there's these two columns, shipping fee and service fee. And if you'll notice, within an order, the shipping fee is always the same and the service fee is always the same. That's not because you have to pay 15 bucks for these pens and 15 bucks for these 3x5 cards. You pay $15 once, or well, somebody paid $15 once for this particular order, right? And similarly down here with Miguel, right? For this order number 4 for Miguel, right? These $9, this shipping fee, he doesn't pay $18 for shipping, he pays $9, right? This $9 counts for just the order number 4. So with things like units and sale amount, it's very easy because we can just sum these columns up. But for things like this, we can't sum this column because we don't want to count these twice. We only want to count it once per order. This actually isn't too hard to fix, but it's not something you might figure out on your own. Okay. By the way, I should say, as we're going through this video, we're going to use some terms and concepts that I've introduced in the Elements of DAX series. So if you hear stuff you haven't heard before, you can go check those videos out and get kind of hip to the lingo, or not. Do whatever you want. But hey, let's actually go solve this thing, shall we? I've got my sales table here, and I already dragged sale amount on there. I'm not even actually sure why I did that. What the heck? I'll just leave it on there, okay? So the sale amount column, we could just sum that up. That's super duper easy, right? But how do we solve this grain shifting problem? And I say grain shifting because right now, the grain, or the meaning of each row in the table, is a single transaction. What we need to do is, within each one of these cells right here, for each calculation, we need to reshape this data on the fly, so it's no longer one row per transaction, it's one row per order. Once we do that, the problem's super easy to fix. So here's how we do it, right? So I'm going to right-click on Sales. I don't have a dedicated measures table, so I'm just going to add it here to my Sales table. I'm going to do New Measure. And I'm going to call this new measure tote, just to save a little bit of space. What the heck? I'll call it total shipping fee. Okay, and I'm going to start by using variables because I always use variables because I love variables so much. So I'm going to type in VAR to define my first variable. I'm going to type in VR, right, which is going to make calling them up super easy. So the name of my first variable is VR order rows. Okay, so the idea here is we're going to create a table that has the rows corresponding to the order. So right now, each row is a transaction. We want each row to be in order. And this actually isn't very hard. Okay, so I'm going to do Shift-Enter, and I'm going to use the Summarize function. Summarize is super duper powerful. You can do all kinds of stuff with it. And gosh, to say like what it does is it's almost too complicated. It allows you to create, summaries of tables. So the thing we're going to use it for is we're going to say, Shift-Enter, we're going to say I want to create a summary of the sales table, but I want it to be shaped differently than just the regular old sales table, right? So you might think that this here, line 4, is a derivation because that's how you would have seen it in my other videos. It's actually a reference. Summarize is kind of doing the derivation itself. So this is sort of the point of the sales table and says, I'm going to go derive something based on a certain shape, right? So for argument 1 is which table do we want to summarize, right? And then we're going to add some additional arguments of how we want to shape it. What we want is we want a new temp table. We want to derive a temp table with all the combinations of order and shipping fee. And this is how we do it. It's just as easy. I'm going to type in sales, order, comma, shift enter, sales, ship fee, shift enter, backspace, closing parentheses. Easy as that, right? So this is a derivation fundamentally, right? Summarize is it's an interesting function that it does all 3 of our main elements. It'll actually do derivations, revision, and iteration. It could do all of them, which is pretty darn cool. Right now we're using it for derivation. So what we're saying is we want to go derive a temp table that is all the combinations of order and ship fees, right? So if we think of our first cell, let's imagine a total shipping fee for Ann, right? What we're going to do, what this bit right here does, is it's going to derive a temp table that looks like this, right? So if we just got all the rows for sales for Ann, because we're looking at Ann, well, we'd get 1, 2, 3, 4, 5 rows. But we're saying, no, I want to summarize that table. I want to derive a new table that is sort of a new shaped version of that sales table with just the combinations of order and ship fee. Well, if we look at order and ship fee, we just look at those values right there, we're essentially going to keep all the distinct combinations of those. And by definition, ship fee is going to be identical for each and every order, and so is service fee for that matter, right? So this here where we get 0, 1, and 15, well, that's unique. This second row where we get 0, 1 for the order and 15 for the ship fee, well, that's a duplicate, so we're not going to include that. Here where we get 0, 2, and 8, well, that's new, so we're definitely going to keep that one. But these other ones, well, those are duplicates, right? So we're just going to keep the unique values of order and ship fee. So because of that, the temp table is going to look like this, where we actually have 2 rows. We went from having 5 rows to 2 rows, right? We've got 2 columns, order and ship fee, and we got 2 rows, which are the unique combinations of order and ship fee for Ann, right? So we've got 0, 1, and 2, and 15 and 8. Okay, cool. So we're not done. We're not done. What I want to do is, in a second, we're going to pass this thing into SumX to go sum up an expression column that we can make based off of this table. Before we do that, though, I want to show you a really cool function that I use all the time called concatenatex. So I'm going to create a new variable called vrResult, right? This is going to be my resulting variable. In fact, I'm not going to call it vrResult. I'm going to call it vrImagine, because this is going to help us imagine what's happening in this calculation. Okay, so vrImagine. So vrImagine, we're going to use an iterator that isn't SumX, isn't AverageX, isn't MaxX, isn't MinX. It is concatenatex. Concatenatex, right? Now, if you've been working with the data for a while, you're probably familiar with the notion of concatenation, wherein you take two text strings and you basically just glue them together. So concatenatex is going to do exactly that, right? It is an iterator. It has an X on the end of it, so it's similar to SumX or MaxX, right? It's going to add an expression column to a table, add an expression column to a temp table, right? But rather than adding up the results like SumX or finding the max value like MaxX, it's going to concatenate all the results together. So, speaking of which, the table that we want to iterate over is vrOrderRows. So we're going to take this temp table, right? The temp table right there that is produced by Summarize, right? And then concatenatex is going to add an expression column to it and then concatenate the results. Okay. So argument 1 is the temp table we want to add the column to. Argument 2 is what is the text string for each one of these cells? Well, for each cell, for each and every cell, I'm going to go get the sales order. Then I'm going to have a little ampersand and have a space, just like in Excel, right? So go get the order, then have a space, and then after the order, after the space, I want you to go get the shipping fee. So I'm going to type in sales ship fee, right? Okay, so for that little 3 question marks right there, it'll say 01 space 15, and for that right there, it'll say 02 space 8, right? So to take those 2 text strings and then stick them together, right? And argument 3 of concatenatex is what do I want to put between each one of those text strings, right? So I'm actually going to put a new line between each one of those, a line break. So I want to show the values from the first row and then have a line break, and then show the values from the second row. So the line break is just unicar 10. So I'm going to type in uni, and my first choice is unicar, unicharacter, right? And I'm just going to type in 10. What does that mean? How should I interpret it? It's a line break. That's all you have to remember. I use that all the time. Unicar 10 means line break. Okay. So we're going to get the order and ship fee for each one of these cells. We're going to put a line break in between them, right? Comma. That's argument 3 of concatenate x. And lastly, concatenate x, which is, as you probably noticed, a bit more complicated than some of the other x functions. We can determine what goes between the text string. It also will say, hey, what order do you want to put these in? Well, I want to make sure we show the first order first and the second order afterwards. So I'm going to type in sales. I'm going to do sales order, right? And I want to make sure I show those in ascending order. So I'm going to double click on ASC. You can also type in ASC if you want to. It does the same thing. Okay. So I'm going to do Shift Enter, backspace, closing parentheses, Shift Enter, and now I've defined my variables. I'm going to type in return, and I'm going to return VR imagine, right? Because we want to imagine what we're working with before we actually, sort of do it, right? Just so I can prove to you that this notion of deriving temp tables actually works, actually makes sense. Okay, so now I've got all that. I'm going to go ahead and hit Enter. I'm going to go ahead and hit Enter. So now I take that total shipping measure that I added, I'm going to drag it here into my matrix. Drag it here into my matrix. And what I could see is the result of the concatenate x, right? So for this cell right here, it had 01 space 15. And for this cell, it had 02 space 8. It took those two text strings and put a line break in between them and came up with that right there, which is, by the way, a pretty good approximation for what the temp table looks like, which is why I like concatenate x so much. It allows us to kind of visualize and imagine what a temp table might look like by using that line break. Okay. Similarly, for Miguel, right? What did we tell it to do? Well, let's remind ourselves. Right? So we went and got every combination of order and ship fee. That's what summarize did. So it got the temp table part of that, right? Not the expression part yet, just the temp table part of it, which we then pass into concatenate x, which is sort of like this bit right here, which takes the temp table, adds an expression column to it, and does something with the results. So the definition of the new column is for every single row, get the order, put a space, and then put the ship fee. So here it would be 03 space 12, and here it would be 04 space 9, right? And then what does concatenate x do with those results, those text strings right there? Well, it concatenates them together. Specifically, it concatenates them together, putting a line break in between them, which is why we get 03 space 12, line break 04 space 9. And this, again, is a good approximation of that temp table right there, right? So if you're me and you've got all these Excel files floating around where you can go sort of draw out the temp tables yourself, that's great. If you're kind of busy, you could use this concatenate x function to kind of imagine them on the fly, which is super duper nice. It only works with small data sets, but I use it all the time. Okay, so good. So this isn't what we want, though. What we actually want to do is for the expression column, let's start with and. For the expression column, we just want to get the ship fee for each one of these rows and then add it up. Well, that's easy to do. So instead of using this imagine business, I'm going to go ahead and just delete that. Delete it right there, and this reference breaks. That's okay. And now I'm going to come in and say, all right, so we've got that temp table. We step back. What I really want to do is take this temp table, add a column to it where I get the shipping fee for each row, and then add it up. Well, that, you all know what that is. So I'm going to create a variable called VR result, Shift Enter, and of course we're going to use sum x for that. It's not sum, but sum x. Right? One of our iterators. It's going to take a temp table that we derived a second ago, add that column to it, and then sum up the results. So the table is going to be VR order rows. So I type in VR, and it gives me this handy-dandy list of all my variables, which is why I put VR in front of all my variable names, even though it makes me look very uncool. I double-click on VR order rows. I'm going to add a comma, right? Okay, so here's the temp table. What's the definition for the expression column? Well, we're done with all that texty stuff. What we really want to do is just get the number. So the number is just the sales ship fee. So I'm going to type in sales, S-A-L, and I arrow down, and there we go, sales ship fee. Okay, so it'll be 15 and then 8, and then it's going to sub it up because it's the sum x function. I go ahead, shift enter, backspace, closing parentheses, and now I'm going to go ahead and hit enter. And, oh, I didn't tell it what to return. Silly me. Okay, so I defined my result variable, but I haven't actually told the return to use it. So I go to the very end of my formula, and I type in VR. Hey, there's my handy-dandy list of variables. And I'm going to double-click on VR result, and I hit enter. And just like that, I get 23, which, by the way, 15 plus 8 is 23, right? That's what that number should be if you sort of glance over here and kind of look at this number. We should get 15. Don't count it twice, just 15 the one time. And 8, don't count it 3 times, just count it the 1 time. 15 once plus 8 once is 23. And you'll get the same results for Miguel as well. Not the same number, but you'll still get the correct answer. Okay, let's do the exact same thing, but this time we're going to do it for the service fee. For the service fee. We're not going to go through all of it. We're just going to use the SUMX part. So I'm going to do new measure. So I right-click on sales, do new measure. And I'm going to call this one total service fee. And what we cannot do is we cannot just use the sum function. We cannot use the sum function and point it at the service fee column because we don't want to be double counting those values. We only want to count it once per order, which means we're going to have to shift grains. We're going to have to take this sales table, which is 1 row per sales transaction, and shift grains to derive a new temp table that has 1 row per order with that service fee number hanging on along for the ride. Okay, speaking of which, I'm going to create a new variable. I'm going to call this VR grain order. I think I might have called it something different in the last one, but I think you guys kind of get the idea, right? We're going to create a new variable that's going to be a table that is going to be a shifted grain version of this table. And what do we want? We want all the combinations of order and service fee, not order and ship fee. We did that a second ago. We want order and service fee, okay? So I'm going to do shift enter. I'm going to do summarize, not sum, but summarize, right? And we're going to use summarize to derive a table. You could do many things with it. We're going to use it to derive a table. So the base table, the one that it's based off of, is the sales table. So I double click on sales, comma, shift enter. Okay, so we're going to drive a table based on sales, but we're going to reshape it a little bit. Specifically, what we want is not just all the rows and columns of sales or all the visible rows of sales. What we want is all the visible combinations of order and service fee. To do that, I type in sales. SA. In fact, I just type in SAL, and I go find sales order. So we'll get all the combinations of order and service fee. SAL, service fee. And that's it, okay? I do shift enter, backspace, closing parentheses. I'm pretty sure if you type in closing parentheses, it'll do the backspace for you, but I just have always kind of done it that way. Okay, now this is going to produce a temp table that looks like this for Ann, right? Because Ann's just those first 5 transactions. We get the 2 orders, orders 1 and 2, and we get the service fee, right? Because we want all the combinations of order and service fee. All the unique combinations, the duplicates, we go ahead and dump. We don't want those, right? Same as before, okay? So now that we've got this new temp table that we generated with orders 0, 1, and 2 and the service fee for each one, well, now it gets really, really easy. So now all I'm going to do is type in var result. This is going to be my resulting variable, the actual answer, right? I'm going to use the SUMX function, SUMX, to say, okay, I'm going to go take the temp table that I derived a second ago, SUMX, shift enter, VR grain order, right? The table that's based on this new grain of 1 row per order as opposed to 1 row per transaction, comma. Okay, so this is the temp table. What's the definition of the expression column? For every single row, get the service fee. And then SUMX will add it up because it's SUMX. If we used average X, it would average it up. Okay. So I'm going to type in sales. I'm going to go find my service fee. There it is. I double click on it. Shift enter. In fact, I'm just going to try it. I'm just going to do a closing parentheses. And hey, it did the backspace for me. How cool is that? How convenient is that? Okay. So we get this temp table. We add the column to it. So we get 5 and 10. And what does SUMX do with those numbers 5 and 10? Well, it sums it up because it's the SUMX function, right? And if we think about Miguel, right, the temp table looks like this, all the unique combinations of order and service fee. So we get 3, 4, 7, and 12. The expression, right, we use the iterator SUMX. We say, go take that table, add this column to it, where we get the service fee for each one. So we get 7 and 12. And what does SUMX do with that 7 and 12? Well, it sums them up because it's the SUMX function, right? Shift enter. In fact, I'm going to do 2 shift enters. I'm going to do a return, and I'm going to type in VR to get my handy-dandy list of variables. I will double-click on result, and just like that, I'm all done. It's as easy to do as that. It's as easy to do as that, right? Not so bad. Now I take total service fee. I'm going to drag it right in there. So I get 5 plus 10 is 15. 7 plus 12 is 19. Works like a charm. Okay. Hey, Brian, what if I wanted total order level fees? So I want the service fee and the shipping fee. Well, I mean, you could pretty obviously add a measure where you just take this measure and add that measure. That would work just fine. You could also do something like this. Let me go ahead and scoop up this code. and kind of cheat a little bit. In fact, I'll even do it from scratch. This is sort of the advanced one. We'll see if you can follow along. I don't have snapshots of what this might look like, but you could probably kind of imagine it. So we're going to call this total order fee. Right? So this is the total fees from the order. That includes ship fee and service fee. There's 5 or 6 different ways to do it. Here's one, similar to what we've been doing. So I'm going to start by creating a variable called VR grain order. Because the grain of this new table we're going to shift it to be 1 row per order as opposed to 1 row per transaction. Shift enter, we're going to use the summarize function. Summarize function, double click on it. And it's going to be based off of the sales table, right? This derivation will be based off of the sales table, comma, shift enter. Okay, so what do we want? Well, before we get all the combinations of order and ship fee or order and service fee, we can actually get all the combinations of order, ship fee, and service fee. Because these numbers are always static within an order, we can actually include all of them together. So it's almost like we're going to take this column and just stick it right there in between ship fee and expression. And to do that, I'm going to type in S and sales order. I want to get all the combinations of order. I also want to get all the combinations of the ship fee and that service fee, SAL, service fee. Okay, great. So now I've derived the temp table that kind of looks like this, except imagine those 5 and 10 kind of stuck right there in between the ship fee and the expression. And now we want to pass that into our iterator, sum x. Oops, the variable is not called sum x, the variable is called result. This is going to be the result of our measure. So I'm going to type in sum x right there. Okay, I do shift enter. So we're going to take that grain order table that we derived, now that has every combination of order, shipping fee, and service fee, right? And because ship fee and service fee are always unique within an order, basically it becomes 1 row per order, right? And I'm going to say for every single row, get that row's shipping fee and add it to that row's service fee, right? So if we kind of imagine the first row, it's sort of a monstrosity of this table plus this table. So for the first row, we get 15 plus 5 equals 20. For the second row, we get 8 plus 10 equals 18. I already forgot. 20 plus 18, what is that, 38? I think we're going to get 38. We'll see. So I'm going to add closing parentheses, and I'm going to return that result. Type in VR to get my handy-dandy list. Type in result. Okay, and just like that, we drop that in the measure, or drop that in the matrix right there, and we kind of have to scroll over a little bit. But hey, there we go. It works exactly as we would want it to. Super duper easy. Now, I'm going to show you one more quick thing that I don't want folks to do. Okay? So to do it, I'm going to go look at my, let's do the shipping fee one. It's a little easier to think about. Actually, let's do service fee. I think it'll work just fine. So I'm going to go ahead and open up service fee. What I will see sometimes, boy, why is that? Is that actually broken, or is it just, yeah, it's fine. Okay, so what I will see sometimes is a variation that looks like this. They use the summarize function, and they go get all the combinations of order, and then they do this. They do this. Service fee. Max service fee, right? And this will actually work. It should give us the same result. I'm going to click enter and hope it does. If it does, I'm going to feel awfully dumb. But let's see. Oh, single value for service fee. Yeah, okay. So what do I have to do here? Min max. Yeah, we got a max right there. Oh, that's why. So yeah, we don't want the service fee. So what's happened is we've essentially added a column to our temp table, and it's got the name service fee. In fact, I'm going to change this name from service fee to new column, right? And then in the sum x, and instead of summing up the service fee, you'll sum up this column called new column, right? Right? And when you hit enter, second time's a charm. It still broke. Oh, that's a typo. Then when you hit enter, third time's, no, gosh. Bad DAX engine. Okay, now when I hit enter, hey, there we go. Got it back working. So this actually does something very, very similar, right? It's going to go take a table. It's going to get the sales table, get all the combinations of order, and for each one, it's going to take the max of the service fee. Now, within an order, if we think about order 1, the max of the service fee, well, the max of 15 and 15 is 15, right? If we think about order 2, the max of 8, 8, and 8 is 8. This new column will indeed have the service fee for each and every order. So then we can then sum it up and we'll get the correct results. But this is really inefficient. The reason being, right, if we kind of write this out long form, what we'll see, change this from max to max x, and type in sales right there. Sales. I mean, I could spell it correctly. What we're saying is, fundamentally, in fact, to be really specific, summarize actually, it's also a revisor. I told you it did all three. So to be even more specific, the really complicated version of what we just typed actually looks more like this. Brian, make it stop. I know, this is why I told you don't do it this way, right? So essentially what we're going to get is we're going to take the sales table, go get all the combinations of order, and create a new column in it, and for each and every one, filter down to just that order, and then go get a whole separate copy of the sales table, and then pass that into an iterator, and do that for each and every order to go get the max service fee for each order. Why would you ever want to do that? This will give you the correct result, but it's got all these extra steps, right? The much, much, much better version of it is to remember that for every single order, the service fee is always going to be the same for every single transaction. So you could write this the much easier way by just doing, something I can actually get to it, that right there, right? So that is the far better way to do it. Okay, so we've seen all kinds of stuff. About how we could use this summarize function to essentially shift grains on the fly, to take a sales table, which is stored at 1 row per transaction, and shift it, and grain shift it to have 1 row per order, right? And we've also shown you how to not do the thing I just showed you. Don't use a max or a min or something like that in the summarize. Just go get all the combinations of the order, whatever that numeric column is, and then you could sum up that column. It'll be much, much, much more efficient. We also showed you how you could use concatenate_x to kind of peek inside, which is also a lot of fun. Okay, lots of good stuff. I sure hope you had fun. I certainly did, and I will see you next video.